Well, I guess we probably get started since we have
Sure.
everyone here. I was going to wait to kind of let people trickle in. We might have other people coming in. So I'll start us off. Welcome to I think the second Dallas Ethereum meetup ever.
Oh yeah, that's actually number 2. My bad.
Well, actually, we're going to go with the DevCon numbering and call that
0.
Dallas Ethereum Meetup 0. And then this being one, because we're all computer engineers here, right? So we'll start properly. So welcome. If you've never heard of Ethereum before, if you're just if you're an enthusiast, you're an actual developer for one of the applications, one of the biggest applications so far on Ethereum is here with us right now. It does deserve a round of applause. Actually, what they're doing, it's actually pretty groundbreaking for what the stuff that he's working on right now. So let me start off by saying welcome to the Makerspace. If you've never been here before, I call this my nerd gym. I pay a monthly fee, and I come in here and I can build electronics. I can use soldering irons. I can learn from old TI engineers how to build a proper circuit. I can build cosplay costume. I can go to the wood shop, go to the metal milling shop, or you can come here and learn about Ethereum. That's what this place is all about. A lot of people come here to make stuff, and the people that you meet are pretty extraordinary. Makerspace paid me nothing for that endorsement. I paid them to come here. This is my first class to host myself, and I'm really excited to have y'all here. So I'll introduce myself real quick, and then I'm going to hand it off to Hudson here. I actually once went to a meetup where the guy said, I'm 32 years old, so I'm going to spend 32 minutes talking about myself in an hour and a half meetup. I'm going to spend 30 seconds, maybe less, hopefully. I'm James. I'm a technology geek, and I really like Ethereum. I've been doing it in my spare time since the announcement. So yeah, please, thank you. And so with that, thank y'all so much for coming. I'm going to hand this off to Hudson. He's going to introduce himself, his involvement with the team, and talk about and do a one-on-one presentation for us, and then we're going to move on to some IoT applications.
Awesome, thanks so much.
Thank you.
So yeah, I'm Hudson Jameson. I'm a technology geek as well. Been involved in Ethereum for about a year and a half. I guess it's only been around for about a year and a half, so since the crowd sale. And yeah, I just really enjoy talking to people, helping people out with Ethereum. I spoke at DevCon. I'm very, very active in the community. I'm a subreddit mod, I'm a Stack Exchange mod, and there's an exciting thing coming up where there's going to be kind of a online Ethereum volunteer core that I'm helping lead. So I'm working with the foundation on that right now, so those details aren't entirely finalized, but there'll be really cool opportunities if you want to jump in and help more directly with the community, because there's always people on the forums asking about all that stuff. But as far as background, computer science background, yeah, I work programming, and I love just doing Ethereum stuff in my free time. So yeah. Cool. So who are we? We are a meetup community. Be here to talk about Ethereum. Gonna have speakers and demos. We are not affiliated with the Ethereum Foundation or any other organization. We're just here because we love Ethereum. Very grassroots, very non-official. All right, so how many of you came in here didn't even know what Ethereum is? All right, awesome, you too. Okay, so Ethereum is a cryptocurrency and blockchain platform with smart contract functionality. So what I've done here is I'm gonna break these words down just a little bit, because that's kind of a lot to take in. So cryptocurrency. So cryptocurrency, you can think back to Bitcoin. You know, that's kind of a popular one that's in the media. It's a peer-to-peer digital currency that uses encryption to make it very secure and very trustless in the way that they transfer funds. So I can do, you know, a transfer back and forth between me and you without any intermediary. Whereas normally if you do like ACH, a wire transfer, any of that stuff, you have to pay a fee. You have to pay someone else to say, you know, I'm going to relay your money because you might not trust that it will get there. This way, it cryptographically secures it so the money gets there every time, and there's always proof of that. Blockchain. So blockchain is a big buzzword right now. It's a decentralized distributed ledger, or you can think of it as a database that keeps a permanent, tamper-proof record of all previous transactions. It's pretty groundbreaking that it can be permanent and tamper-proof by the way that it's just set up architecturally. We've had the different pieces of technology since around the late 1980s to do something like a blockchain, but it wasn't until Bitcoin came around that someone actually put all the pieces together. These pieces of decentralization, the pieces of the consensus algorithm, the pieces of keeping it, distributed amongst the participants in that network. So how is it tamper-proof? How a blockchain works is I have a database, and you can think of it like an Excel spreadsheet. So I have a database, and that database is electronically shared with everybody at the same time. We're all kept in consensus on what the state of that is, and if there's a change on it at all, we all have to agree to it. So say I get a sheet, electronically pass it around the room, it all stays updated. The next time another transaction, and the next time another piece of data comes through, it gets added to the chain, and we all have to agree with it. So it's decentralized, meaning all of us have access to it, but all of us have to vote, or all of us have to put our say in on what gets on the chain. And once it's in there, cryptography allows us to place restrictions on it being tampered with beyond that. So that's immutable, permanent, whatever you want to call it. It's an append-only database if you're in the banking or financial institutions. And then smart contracts. So I'm going to explain this in a little more detail in a second, but with blockchains, generally people think of Bitcoin and it has one function. You're transferring Bitcoins to someone else, you're obtaining Bitcoins, whatever. It's one function, pretty much one use case, with the exception of some multi-signature stuff that you can kind of manipulate the chain for. With smart contracts, let's take a blockchain, and instead of just having it have that one use case, put any program that you want on the blockchain. Once that program's put on the blockchain, it inherits all of the previous things I described about the blockchain, such as the tamper-proofness, the decentralization, how it's distributed. So pretty much you can have a program on the blockchain that's going to run exactly how it's programmed every time, without the possibility of censorship, downtime, fraud, or third-party interference at all, because it's immutable. It's on there, and once it's on there, you can't do anything. You're probably thinking, well, then what good is that if you just put something and you write it down one time and put it on the blockchain? Because it can't change, so what good is that? That's just the same thing as doing a transaction. But what they've done is they made it so that you could put these computer programs or these scripts on the blockchain, and they have state variables within the scripts, within the contracts, that can change through function calls. So you can have mutable storage on an immutable program. So you do your program, function A, function B, function C. You can't change those functions, but if there's variables within there, those can change. So in a nutshell, that's all of the stuff. How many buzzwords are there? 1, 2, 3, 4, 5, 6, 7, 8. I counted 9. I'll count more. And the media all the time are just like, this decentralized, buying drugs, immutable, distributed, and they just throw all these words together that they don't mean anything. All right, because the last slide was too wordy, I'm going to go through and just walk through how a blockchain works through images. So what we got right here, someone wants to send money from A to B. So the transaction is represented as a block or a transaction in that block, depending. That block is broadcast to everybody, like I was talking about. The ledger is shared, the database is shared, so we all get the same exact copy. And then those in the network approve or not approve of the transaction. They wouldn't approve of it if it was a malicious transaction, which the network is able to detect and the software is able to detect. The block can be added to the chain, and that provides an immutable record of the transaction. And then finally, the money's received. All this happens in variable time depending on what blockchain you're on, and there's many different kinds of blockchains. The one we're talking about today is Ethereum. So now let's jump to Ethereum. So this is what is called the beginner's guide of Ethereum. So I'm not going to read through all this, and these slides are posted later so you can read through them, but I'll kind of walk through how Ethereum is different, how they've kind of done a paradigm shift in how traditional blockchains are created.
I had heard this graphic was being updated. Is this a recent update?
This is the update from 4 hours ago.
Oh, right.
I'm Art. So, on the left, you see a decentralized network. Again, just going over those high points. No central point of failure. Very reliable because everyone has a copy. Everyone contributes. And it's cost effective because you don't have to have that redundancy of backing up your database everywhere because it's automatically backed up by way of the architecture. And so if you look on the right, it's kind of showing how, yeah, most of them do use a central authority to do this, like and the Bitcoin blockchain is, something that was created to get around that, to not have an intermediary or central authority. So so we have, the concept of BitTorrent kind of helped mold some of the ideas behind Bitcoin. Then we have Ethereum. So you can think of Ethereum as the world computer. If you know hyperdrive or virtual machines, think about putting a giant distributed computer on a blockchain and harnessing that power of consensus, harnessing that power of immutability. So that's kind of what Ethereum did. There are different programs in the Ethereum ecosystem. Ethereum, compared to blockchains like Bitcoin, Ethereum's seriously trying to boil the ocean. So what it's doing is it has things like Mist, which is a graphic front-end wallet that's going to kind of be like an app store for what they call decentralized apps, or dApps. They also have, of course, their cryptocurrency, which is called Ether. Ether is a cryptocurrency that is used to fuel the things on the network. So if I have a contract, a script on the network, it can't just, what's the incentive for someone to go and run that script for me or verify that script for me? So I have to pay a fee, and that fee is in the form of Ether. Just like in Bitcoin, there are transaction fees for transferring a Bitcoin. So you can think of Ether as the fuel of the Ethereum network.
How does the Ether come into play? Like in Bitcoin, you either mine or buy. How do you
Right.
get Ether?
Good question. So Ether comes into play through mining. So you have miners mining and processing So it's the same way that Bitcoin has it. In the future, and this is not involve mining, and that's going to be a very, very separate way of consensus. So this just kind of talks about how you can order your own detergent. When the laundry machine runs out, it can detect that, order it itself. There's some examples of some businesses that have started. Maker's an autonomous bank. Slockit, you can have like an Airbnb style, but without the third party that's dealing with those transactions. You got Uport, which is an identity solution on the blockchain, and then we have Augur. And actually, you might explain Augur better than I, as you were in it. So how would you describe Augur? It says a decentralized prediction market.
Well, I mean, that kind of describes it. I mean, you can describe what a prediction market is.
Would you be willing to introduce
Yeah.
yourself to the group?
I'm Ryan. I work for Augur.
And Dynamis.
And Dynamis. Hey, there we go.
Dynamis.
I pay half your paycheck.
So, Augur works on prediction markets. That's to bet on the future. Any event that could be happening in the future, you can bet on it, and that the crowd wisdom allows you to get accurate odds of anything happening in the future, which has a lot of useful applications. Like my favorite example is was a corporate application like with Xbox sales. So let's say Microsoft is about to release the next version of the Xbox, and they have a sales prediction number on Augur, and that Augur's prediction for the number of sales is going to be more accurate than any experts that are at Microsoft or any kind of pundits could come up with. This is something that's been shown about prediction markets in general and empirically shown. Let's say they make an announcement saying the camera's going to be spying on you 24/7. Well, they can actually see how much their sales are going to be impacted by that announcement and know if they need to undo that decision or not. So it provides very useful information for not just the business world like that, but for anything in the world, including like chance of flood for farmers. They know how much to worry about. Or if there's going to be a major economic collapse, should I be putting 10% of my savings into prepping, or should it be 1%? You can be reasonable about this. You don't have to go all out or nothing, because it helps fix especially things in the world where there's big polarity of information inequality.
With one caveat, which is that these markets have to resolve. So markets that are going to resolve years from now, that means your money would have to be locked up for years. Right.
Yeah, your money. You could have your money locked up for years, although the odds would change over the years, and you could withdraw some.
So users are betting.
The price of your shares change.
Users are betting on what the outcome is, and then that crowd mentality more times than not predicts the truth, or almost every time predicts the truth,
Yeah.
is what augurs are.
It's the most accurate known, prediction markets are the most accurate way of predicting the future that's currently known. And augur is, because it's decentralized and trustless, virtually all of the costs that come from having a prediction market, like regulation, having to trust the centralized people that manage it, all of that is gone. All you really end up having to pay for to keep augur running is to compensate the person for posting the initial liquidity and to pay the reporters to make their final decision on the market, which is like a matter of dollars.
Huh.
Would you be willing to do maybe a future meetup and walk us through the whole platform and everything?
Yeah,
how
I
it works?
could give a presentation.
All right,
so I
awesome,
think,
cool.
We'll set that up. So yeah, awesome. So that's Augur, and that's exciting. We'll be looking forward to that. So how is Ethereum funded? They had pretty much the most successful crowd sale for a cryptocurrency platform of all time. They raised at that time 31,591 Bitcoin, which is equal to $18 million. Now this was at the time when Bitcoin was around $600 a Bitcoin. Now it's at 300, and it's gone as low as 200 since their crowd sale. So you know, it goes from 18 to 7 to 9, and it just, they've been having to deal with the issues of bulk selling their Ether at the right time. So, or their Bitcoin, I should say, to get Ether. But the foundation has actually proved really resilient. They now have funding for multiple years, definitely, and they're working to secure outside funding as well. So here's the release dates. So November 2013 is when Vitalik Buterin came up with the idea. He got together with some people within in 2014 to come up with some of the formal specifications of it. There was the crowd sale that happened July of 2014, and then we've had these proof of concepts all along. And then the big deal was the fact that Frontier, which was the official alpha version of Ethereum, was released July 30th of 2015, and then Homestead, which is the next release phase of Ethereum, is going to be coming March 14th, so Pi Day. So that's real exciting because that marks a period of time between that July 30th, 2015 date and now that there's been stability within the Ethereum network. So that's enough time in most people's minds to prove out the usefulness of Ethereum, to prove out that it's not going to come with a consensus bug very readily. Obviously, that's always a possibility, but they wanted this whole time for testing and to be able to roll back the network. But it's actually proved to be incredibly stable.
Do you think you could zoom in a little bit on that image, like control and scroll kind of thing?
Yeah.
Thanks.
There we go. Oh yeah, that's a better idea. So there we go. There's the timeline. And yeah, this is actually on the Ethereum subreddit at the first page, and it'll also be in my slides as a clickable link. So if y'all want to look at this afterwards, feel free. So next, what do we got? So, all right, so smart contracts. So smart contracts are, like I said, like an Ethereum scripting capability within the blockchain. So if any of y'all are familiar with assembly code, smart contracts, they get, kind of compiled down to that bytecode or assembly code. But before then, there's a high-level language called Solidity that they built specifically for Ethereum smart contracts. It kind of looks like JavaScript, has some little hints of C, I feel like. And what it does is it's a high-level language, so you can, let me pull this up. So you can write things like contract my token and make function calls and if statements and variables and all kinds of stuff. And it makes it really easy as a developer to kind of jump into Ethereum and start writing these smart contracts for the Ethereum network. So the other thing is on the right here, I kind of demonstrate how the process of a smart contract, happens. So this, is this hard to see? Okay. Oh, okay, you can see the big words. So we have functions here, and those functions stay the same, but you sign transactions to change the state variables. So things like the storage elements down here, purchasers and purchasers list. This particular example is about a purchase page on some band's website. So we got the shipping page, the website purchase page, and the admission page. So all of those can all be, the backend functions can all be housed on a smart contract, and you can make calls to the Ethereum network through signed transactions to do things like purchase an album, and it maybe sends you a code back to download the album, or claim an album. If you know, you want to ship it to your house, you put the shipping information. That's state variable storage that you can put into the smart contract and it act upon. Contracts can also call other contracts. So think about this contract as like the band website management page, but maybe they need a shipping contract to say, okay, as soon as someone purchases an album, call this other contract and have it ship the CD to them. In the future, it's going to be call this other contract, which talks to a drone and autonomously delivers your CD. And there actually is a project that's dealing with drones right now in Ethereum where you pay a drone money in Ether and the drone will go to the coordinate location you want it to. That's crazy, right? You can pay a drone to go where you want to in a decentralized way with assuredness that the drone is not going to fail because of the smart contract language and the immutable, you know, blockchain. So as far as use cases go, there's a bunch. A lot of them are just being realized every day just because blockchain is such a new technology. So some of them, we have Augur here for the decentralized market platform. Let's see, we got things with cars, things with shopping and e-commerce. So for instance, escrow is a big one. You can have escrow on Ethereum with like literally 10 lines of security code. So, I mean, that's really powerful when you have a decentralized computer, you know, being able to secure an escrow account. And these smart contracts, they can hold their own Ether balance. So, I mean, the possibilities get immense at that point. Ride sharing, they're doing some apps for ride sharing. They're doing some for decentralized storing on a network of computers. There's just, the possibilities are crazy. So, how do you get started? You get an Ethereum client, and then you build or use a dApp. So the client's, the easiest one to use is called Mist. It's like a graphic client, so it's super, super easy. And then the building and using a dApp, you can either use a dApp if you find one. I'll send out a link with a dApps list attached to this PowerPoint after the meeting. And also, if you want to build one, that's where you're going to come in and demonstrate the Internet of Things example. And then, of course, as I mentioned, the Homestead release is coming, and so when that happens, I've already seen previews of the website. There's excellent tutorials on ethereum.org once the new website comes in. Right now, there's good tutorials, but these new ones I've seen, they're excellent. So they can really help you jump in, get in there fast, and learn it. So yeah, that's the end of my slides. So let's go on to the demo. And we'll have question and answer after, right?
Yeah.
Sweet.
And feel free, I'm going to see if I can't get both displays up so I can get everyone here looking at everything real quick.
Sure thing. Actually, while he's doing that, does anyone have any questions?
I have a question.
Yeah, go ahead.
Can you speak about private blockchains versus public blockchains and the
Oh, yeah.
applications that you talked about? How many of them are private, how many of them are public?
Sure thing. So, the Ethereum blockchains we've been talking about are public blockchains. So that means anyone can connect to it. It is permissionless. It is decentralized fully. It is completely like in the open. So there are two other things. Yeah, go ahead, Ben. Look at that. There we go. So there's three broad kinds of blockchains. There are public, there are consortium, and there are private. A consortium blockchain is less decentralized than a public blockchain, and it has permissions on who can enter it. So think about a private network of like 10 taco shops. If they have a consortium blockchain, they can share all their sales figures within their own, within their blockchain, and it just be just for them. Other people can't join it. So you would think, well, you know, that takes away the property of the blockchain, but it actually doesn't, because even though it's not completely decentralized and completely public like the Ethereum or Bitcoin blockchain, it still has the quality that you don't trust those other competitors. You're in this network without a central owner. In order to share information you might need to share on a permission basis, but you still have to kind of use some democracy in there. You still have to use some permissions that are granted based on voting. So that's the consortium chain. Then you have private blockchains. Private blockchains are blockchains where there is one owner of it, there is one company or entity who is managing the blockchain. So at this point in history, a private blockchain is a database. It's a glorified database because you're using the word blockchain. In the future, and this is something that multiple people are working on, there's going to be private blockchains in every organization. Every major organization, even individuals, will have private blockchains. And there's going to be mechanisms that you can share individual transactions or transaction blocks or certain permissions between your private blockchain and another one. There's also concepts called side chains that kind of delve into that. But at the same time, private blockchains, if you were to go and talk to, if you like work at a big business or company, they're like, we want a private blockchain. You'd have to tell them, you want a database, because blockchains are incredibly inefficient to do database procedures. So yeah, private blockchains are not the way to go right now.
Well, I think you're saying that they're in the future though they'd be ubiquitous inside private organizations. Would you say that's because of ability to audit easily?
Yeah, the ability to audit easily, and the fact that there are things going on right now, IBM and Microsoft and a few others who have blockchain as a service offerings, so that makes a generic fabric of blockchain, meaning anyone can jump in and join. And now, then once they just get it down to this fine-grained permissioning we don't have today to be able to share individual transactions, that's when a huge difference is going to be made. Because then I'll be able to have my private blockchain and share just the information I want with your blockchain. So it will be less decentralized even so. They might find some ways. I guess the research isn't done. There might be some ways to keep it very decentralized. It's just something that isn't explored right now, just because there actually isn't a consortium blockchain that is active in existence beyond test. So we have to get to consortiums before we can get to private sharing with other private blockchains. But if you're looking for information on that, Interledger is a project from, I believe, the people who made Ripple, and they're working to do something like that, as well as, I think, yeah, IBM's also kind of trying to do that in Hyperledger with their open blockchain
And then Tendermint.
and
And Eris.
Tendermint. So Eris is trying to do all of their. They're actually, Eris is kind of trying to do that with their announcement the other day. I didn't think they were, but it seemed like they pivoted a little bit. And Tendermint, they're a whole other story. I haven't looked into them enough. So
I think Tendermint and Eris are partners together.
they had shared developers.
What you didn't really mention there, what you were saying, consortium blockchain, an example of use of that, and I had heard that there's banks working on doing research on that. It would allow banks to do quick transactions between each other without having to mail things.
Yeah, and same with
Very
the
large
stock
amount.
exchanges.
What?
Same with the
I
stock
have
market
to use
exchange
this
too.
display here
Yeah.
for us
Yeah.
if that's all right.
Well, do it.
Then NASDAQ is trying to get down their settlement time in 20 minutes using the blockchain.
Yeah, because like if you got 3 days transaction time, that's a liquidity.
ACH
issue.
is, yeah,
So
3 days,
You can
that's
save a lot
great.
of money by doing blockchain. So there's
Yeah,
there's
definitely
major
taking
banks working
advantage of
together
the
on
3-day settlement
putting
time
that in
myself.
Take arbitrage out of the picture.
Hmm?
If you can do it shorter, then it takes arbitrage out of the picture.
Not necessarily, it depends on the kind of arbitrage, but it takes out of the picture people like me who will sell a call and completely forget about it and have 3 days to buy it back for way cheaper.
Yep.
All right, so I wanted to kind of pull some examples, but I want to kind of first pose the question: why use Ethereum for IoT, for Internet of Things, right? And I wanted to kind of show you a headline from just this week. It was actually Dr. Gavin Wood, one of his tweets talked about, posted a link to this site where this guy bought 2 light bulbs that were made in 2012. He plugged them into the system and just completely walked through the whole thing, and how they opened up security holes to his own network. He was able to gain root access to these devices. Just really simple stuff, nothing crazy. Just running requests through proxy and actually sniffing packets, and really low level simple stuff to actually find out the problems with it. If I go further back in time, I can talk about the baby monitors that were displayed onto a website for anyone to go see into people's homes because people had exploited that hack. Going back even further. Or I think even more recently than that was a really popular home router. Had a back door in it for years, which means anyone could sniff all of your network traffic internal to your own home, and then get access to those devices. So, and it's kind of scary, kind of being in the technology world and seeing the products that are on the shelf at Home Depot, that what people can buy, and seeing kind of what security holes and the amount of really poor security practices and development that actually make it to the shelf these days. it's kind of scary stuff. Why I like Ethereum for an IoT platform is I'm going to pull from what Hudson was saying before, is that identity is on there, right? Identity is inherent on the blockchain. I can't interact on the blockchain without a wallet, a contract address, and keys to actually transact with this. So I have to have an identity, right? So security is inherent in it, and identity is inherent in it too, because when I send a transaction to the blockchain, like just like if I were on a request, like so if I had my cell phone and I'm using my Facebook app and I send a request to log into Facebook, right? So that's a request to an actual server. But when I send a request to a client, that transaction itself is cryptographically signed. It cannot be spoofed. No one can say, "Hey, I'm James," and do this thing for me if you've programmed your application to say only do things for James. So that's why I like it as a platform. What I'm going to demonstrate to you is real simple. This is the Hello World app of Raspberry Pis, right? Make a light blink, okay? In this case, our actuator is a light, and we're going to make it blink. But the actuator could be, and I have two of them. And you may ask why I have two Raspberry Pis, but does anyone want to ask why I have two Raspberry Pis?
Why do you have two Raspberry Pis?
Thanks for asking. I'd like to tell you redundancy, Hudson. Because the last time I tried to do this demo, the whole thing didn't work. I had the time warp bug, and I think that was client 132 just immediately showed up, and that was when your block node was actually waiting for like 6 hours ago, which would never occur. So what I'm going to show you is a node that's installed on my Mac here that's communicating with the blockchain. Okay. There's also a node on this Raspberry Pi and on this Raspberry Pi. So all three nodes are communicating and participating in consensus right now, and they each have a blockchain running on them. To show you what this actually looks like, not really much to look at, but what you can see here is my console for Geth, and Geth is the client I'm using. What's unique about Ethereum to, I think, other blockchains is that there's multiple implementations on the client level, right? So we have Geth, we have C++. What's Gavin's new? Gavin Wood's
Parity?
Parity,
It's in Rust.
Parity and Rust. It's supposed to be optimized and
Blazing
insanely fast. Yeah,
Yep.
insanely fast. And on each of these nodes, I actually have a full copy of the blockchain, right? And that's not necessarily a great setup for an IoT device, but what's coming, especially in I think pretty aggressive timeline in Gavin's client, is a light client, and that's really like the holy grail for IoT stuff. So I won't have to have a full download of the blockchain on these individual devices, and we all know that Raspberry Pis are just a prototyping platform, right? If you go down to Samsung Arctic, you can get a chip the size of your fingernail that will do the exact same thing, embedded in a device and and do whatever you'd like it to do. So that's going to be fun when the actual light clients are released. But what I'm showing you today is actually a full client, has a full download of the blockchain itself. You can see it outputting to the console, and one quick number to pay attention to is the actual block number. So you'll see it kind of output block numbers as it's going through the blockchain and finding consensus. This is my local node here. I'll show you what it looks like on the Raspberry Pi. Pretty similar, right? And it's on block 1095769, and then I have the equivalent block here on my local machine. Okay. So what I've done is actually I've used Solidity to write a contract, which is just a fancy word for an application on the blockchain, and I deployed it to the blockchain. Right? I'm trying to explain this to people. I say, okay, well, in words that they would understand. Say if you came from like a web development or an app development background, you say, if I am if I'm using my wallet to communicate through a node to a smart contract on the blockchain, what that really means is I'm an authenticated user using a client to communicate with an application server on somewhere. Right? The way that I'm communicating with the blockchain on these devices isn't really optimal, but we'll kind of show you how we can fix other lighter clients at a later time. Anyway, let me show you what the Solidity contract looks like. So here is just a really simple contract. I've made this available to y'all on our github.com, github.com/Dallas Ethereum account. It's one project in there, it's IoT Blink. This is the Solidity contract in there. Really simple stuff. There's probably poor programming in here. Don't use it as a basis to launch your IoT empire, okay? But it has a setter, a getter, and we're using an event function within the contract. Event functions are kind of fun because you can call this event function and then you can monitor a contract with a client. And you can use that event to communicate states of your application out to anyone who's looking at that particular contract. This contract also doesn't prevent anyone from using it. So if anyone had the contract address and the ABI, they could actually do the exact same thing that I'm doing here. In fact, I encourage y'all to. It's in the source code for you. So, excuse me. So I've already deployed this contract out onto the blockchain. It's sitting out there. It has an address. Have y'all seen what an address of an application on the blockchain looks like? It's basically just this long hexadecimal string of characters. It's just as hard to guess that address as it is to essentially break someone's password. Probably even more so.
It's pretty much impossible.
Yeah.
That address is generated by the code, your username, and a nonce. So how many contracts you've ever deployed? That's impossible to guess. You know, it could be 1, it could be 1,000. So they combine that all and hash it.
So deployed this actually a couple months ago onto the mainnet and did use this as a demo for different things. And so I also wrote a using the Node.js. Yes, sir.
So this code right now, if we downloaded Geth and we could execute this, what IDE would we be?
Okay, that's a good question. I actually deployed this using the wallet client.
Mist or something?
Actually, no, the Ethereum wallet.
Yeah.
So if y'all download this, then they just released a new version of this right now. I can deploy a new contract directly through the client right here. So what I do is I just click this code here. I put in my Solidity source. It generates the bytecode, which is the equivalent of compiling it, and then sends it up to the blockchain. It'll give you an address. And what I like about this Ethereum wallet client is now I can go in, I can take that address, I can give it a name, and I can monitor that contract. Now, so this is the actual contract address that I was mentioning before. Of what you're going to, how you're going to communicate with it. In this tutorial, when I'm walking through here, I'm going to assume that you can SSH into a Raspberry Pi, right? But then, other than that, if you can get that far to program to monitor this contract. If anyone's used Node.js, then you'll be familiar with modules. Modules are just essentially a class that you. Is there someone give a better description one? Because on this one, I actually have the GPIO stuff commented out, but I could just show you anyway. So I instantiate my Web3 object. Now, where I run this, I'm going to run this on a Node.js device, this, or this. And I'm also going to have a node running and communicating with the blockchain because this program is going to look for that local node to actually interact with the blockchain, right? So I have my Web3 object instantiated. I'm using some GPIO functions here. On-off is another module, so npm init. npm install on-off. Pretty easy module to use. And I'm setting the actual LED pin on the Raspberry Pi with which I'm going to interact with. So I'm saying this pin, not this other pin way over here, right? In order to interact with it. And then I'm going to set my provider. That's, again, my local host. Has anyone here done a remote host successfully?
Yeah.
Yeah, okay.
Yeah.
So it doesn't have to be a local node, but it can be a remote node that's allowing you to communicate.
Yeah, you can use a remote node. There is a lot of hoops to jump through as far as permissions on the node and on your network.
Mm-hmm.
So it's a task, but it can work.
Is the interactive platform.
Mm-hmm.
I'm just doing tour.
So what I'm also doing is I'm confirming that I am connected to my node, and I'm just outputting some stuff to the console. I'm saying what's the version, is it connected? saying what's my Coinbase. So my Coinbase is just essentially what is my default wallet within my node, right? My default identity that I'm going to interact with the blockchain. I'm going to print the ballots just to kind of get some stuff here. Now, here's where things get kind of tricky. ABI string. This was a nebulous concept to me, and I think someone at DEFCON 1 properly explained it to me. And it's just essentially like a definition of the class that you want to interact with, and that class being that contract on the blockchain. You can see this is what an ABI looks like. And you can see how long it is, and that is an ABI for that contract that I just showed you, right? There is a web client that I think you turned me on to, Hudson, that generates this ABI for you automatically. If you just copy and paste the Solidity code into it.
It's called a Ethereum online compiler, and what it does is, you type in the contract and it automatically generates it. Also, I mean, Geth can also generate it if you put the contract code in. So it's pretty universal. Also, the Ethereum wallet you were showing can do it. I like to think of it as like every JavaScript call to a function you need, because that corresponds to the JavaScript functions you'll be coming up with, I'm guessing.
I will note that the output does not put the proper quotes in for this string definition, so you kind of have to go back and copy paste the right quotation.
It works for me some of the time.
Does it?
It just depends on so sometimes you do have to parse it with JSON. The online compiler you don't have to. That's what it is.
Oh, okay. So this is where I get hung up without replacing the actual quotes on it. So here it says, what contract are we going to interact with? So I'm going to define a contract address. That's the address on the blockchain. Right? I'm going to set my default account. Can't interact with a contract if it. Again, there's identity. Now retrieve your contract object, the ABI, and the contract address value. So I'm going to store that in a variable called blinker, and I'm going to log to the console that actual object. That's going to actually output my ABI again. So now this guy right here is my event call. So I'm going to say, if that event fires on that contract, do something. In this case, I'm going to blink and output the actual block number for us. And if everything goes well, I can demonstrate this for you here shortly. So I know that was a lot. Before we go on to the actual demo, any questions so far about what I'm doing? Maybe this will make a little more sense and actually demonstrate this.
What's the trigger that's making the light go off?
Okay, that's a good question. So this is monitoring for the event within the Solidity contract. The event here is called when I set a value. So I'm storing an integer on this, real simple basic stuff. I'm storing an integer on this contract, and I'm going to fire off my event, and I'm going to send it what I sent to set the contract variable.
But there, I mean, you can get as fancy programmatically as you want. You could look up the IBM stock price or whatever the value of pi or something stupid.
And
the event.
Precisely. And I think this is something that Augur took a real creative approach to solving, which is you brought something into to mind when you said look up the IBM stock price. Well, what is the truth? What is the gospel for that? Right? There's the idea of smart oracles that I think Ripple tried to popularize with their programming language.
Yeah, they had like Codius or something.
Codius.
You can on Ethereum, because it's deterministic and because it doesn't touch the outside world, it just kind of takes in input and gives you some stuff back. It can't natively just talk to a website. I can't just put in, at least not in Ethereum's language. Now there's other blockchains that might let you do that, but you can't just say, go to this IBM API to look up the stock price, or go to this stockmarket.com API. There is something called Oracleize, and Oracleize is a company that has a product where you can have a smart contract that lets you interact with the outside world and call Wolfram Alpha, let you call an API. And it's really neat because it uses TLS Notary, and TLS Notary is something that cryptographically signs a signature saying that this was looked up at a certain time and date. So now you have nearly trustless, you're having to trust Oracleize still a little bit, and you are having to pay a fee for that information, but it's really small, so I think it's a penny each time that you look it up. And actually some of the calls are free depending on how often you look it up. So I check out Oracleize if you want more information on that. They explain it much better than I would, but that's the way you talk to the outside world when you're in Ethereum.
Excellent, thanks.
So the JavaScript that you were showing,
Yes,
is
sir.
that actually, I guess line 58?
Yes, sir.
Is that actually going out to the Ethereum blockchain and getting your API of your contract?
Yeah. Actually, I've defined the ABI already, and I think up to this point it's hoping that it's gospel. I don't think that there's any actual check against the true
Well,
ABI.
Wouldn't it have to go out to the blockchain to get the API of your contract?
No. I so far I haven't done anything in terms of interacting with the blockchain up to this point. The only thing I've done is defined a ABI at a particular contract address.
When he calls Blinker though, what it's going to do is it's going to take the ABI and take the contract address, smush them together and say, this is my unique ID I'm talking to the blockchain on. And if it doesn't match, then that means he put in the ABI wrong or he put in the contract address wrong. So you can think of it as a username password to interact with the smart contract, with the ABI being the more complicated one. And by the way, ABI is a variable he defined. It was that long string of stuff earlier.
The ABI contains some kind of reference to what that itblinks function would be.
Correct. Yeah. So
On
let me kind of walk you through here. So inputs, right? Yeah, I'm going to basically be able to set an integer with the value of x, right? It will show me constant true inputs, something to get outputs, name, right? Value in function, false.
Maybe you could just go like step by step from like what the computer, what you're about to do, like what the everything that the computer is gonna do. Like it's
Oh,
gonna
if you
do
go-
this first, and it's gonna like do this, and it's gonna send to here,
Mhm.
Yeah.
and get this, and then it's gonna find that out. And
You could actually
So
go to
on.
the online Solidity compiler, put in the Solidity code, and it'll pop up the ABI, but I don't know if that'll help the explanation anymore. It'll look a little better, but that's it.
So here is the portion where I'm actually, oops, sorry.
I guess if you could put that in a JSON printify or something so we can see it on multiple lines.
Yeah, let me, let me do that after the demo and provide to the class. But really where I'm most interested in terms of the ABI, what I'm gonna interact with is this portion of it right here, which is my event that it blinks, right? Okay, here's a button here. So, so when the event fires, I'll blink a light. So should we try the demo? It's going to be really underwhelming.
Real quick, is that watching for the event? So
Um,
up there, is that just a thing that's like watching and it's just polling over and over again for the event?
Correct. Yeah.
Okay.
Yeah. So it's that object now is it's just basically waiting for it to fire and ready to do whatever you ask it to do when it does.
So are events more like broadcast messages?
Correct. Yeah. Yeah.
So does that mean that these devices always have to be polling the blockchain to be able to be triggered?
So the way I understand it is you told your node that you're monitoring a certain contract, and that node's going to monitor all contracts at all times, right? But when this one contract does this one thing, then I'm doing. So I'm not necessarily a true like client-server relationship.
You've got like a copy of like the Ethereum blockchain on your computer, constantly being updated, and it's just watching a file on your computer.
Okay.
Yeah, since it's constantly being updated, it can still be asynchronous, but you don't have to poll it and have all the negative side effects of polling that you would normally have polling like a web server, because it's your local files.
Mm-hmm.
Okay, so here's my local node, and that's what I'm going to use to connect my wallet with, right? Here on the left is one of the I don't know which is which, but here's one of the Raspberry Pis, and I've set my, let me see here. I'm running that JavaScript file now on the Raspberry Pi with using Node, right? I do have to use sudo because of GPIO control. That's just one caveat here. I try to run this without admin rights. It won't actually allow me access to the GPIO pins through Node.
That's a limitation for Raspberry Pi.
Yeah.
Yeah.
So here's the stuff that I wanted to output to the console to kind of show y'all. So it's giving me version, does have access. I'm running Geth 134 even though they released 135 today. And then I'm watching this contract and and then outputting the information from that object, all the information from that object that I created with the ABI and the contract address. Let me do the exact same thing on the other one here. So, same setup, okay, I'm all set. I'm on block 5832 here, 5832 on my local node. Looks like just incremented 5833 and that 5833. So all three nodes are all synced. Now, this is my local machine wallet connecting to my local node. I'm going to send I'm going to set the value of that contract. I'm going to call 434. Or I'm going to actually, let's do 314 since Pi Day is coming up. And I'm going to execute on that contract. The way that I set this up in the client was I just had the address to the actual contract. And I said I wanted to monitor this contract and interact with this contract. And this actually saves it within this tab here on the Ethereum wallet. So I'm going to execute it. I have to sign the transaction, right? I'll enter in my Fort Knox of passwords. You'll see that the transaction here on my local node was included and will be included in the next block. Now, as we wait for this to execute, I want to talk about speed and scalability. With the proof of stake change and with something that Vitalik calls Vitalik Buterin, which is one of the co-creators of Ethereum, calls sharding. This is actually going to run in much faster block times and hundreds of thousands of transactions per second. So highly scalable stuff if they can pull it off. What this is actually doing now is it's waiting for its turn to be included in the blockchain. And it looks like I picked a time in the blockchain to be a minute since the last block. Oh, here we go.
There we go.
So my transaction was actually picked up. Now, in the next block, we should see blinks.
There we go.
Here we go. So
Alright, awesome.
that was a cryptographically signed transactions to a smart contract on Ethereum to control an IoT device. In this case, our actuator was a light, but could be many other things.
Could be a coffee pot.
Sure. Yeah. Now, one of the things I didn't do in the contract was I didn't check for my identity, which is very easy to do within the Solidity code. To say make sure that sender equals something specific. So anyone can interact with this contract, but if you wanted to say lock it down to certain specific wallets, then you would have a Fort Knox of applications sitting on this blockchain. Depending on how strong your private keys are stored in your password, to essentially control IoT devices. Now, what's very important about that whole exchange that a lot of people need to grasp, and I think this is where people get mostly like the aha moment, and the buzzword these days is serverless architecture, right? That transaction went to the blockchain and back down to these devices without an intermediate computer, right? So Google couldn't shut that down if they didn't want that to happen. Twitter couldn't censor that if they didn't want that. And this is kind of really the power of this whole thing here, is that other than these three computers here, or granted I have some redundancy with the actual IoT device, but other than these two computers, that there was no other intermediary to execute that transaction.
You'd have to take down the entire network of thousands of nodes, and now thousands of nodes have his transaction in a block. Like I'll go home tonight and sync up the blockchain, I'll have his transaction there.
And if you happen to be running a node at home, then you can still do your own stuff anyway.
Yeah, precisely. So that's it. That's my IoT demo here. Real simple. Blink, hello world.
So how much did it cost you in Ether to turn on the LEDs?
Actually, to interact with the contract was actually pretty.
It's like a fraction of an Ether, I guess.
It was a fraction of a fraction of a fraction of an Ether. It was.
Yeah.
It's minimal.
So it's like on the order of Satoshis. Then,
If you go to wallets, I think, and then you scroll down, it'll show pending transactions. And it'll say how much was sent if you click on it and look at details.
Sure. So here's one I did an hour ago. This cost.
Yeah, 0.000, yeah.
0.001 Ether, so 7/10 of a cent, I think.
Yeah.
So that'd be.
So ethers are $9 right
Oh
now.
no, sorry.
Yep.
Oh, so almost a penny.
Yeah.
Almost a penny to run that transaction there.
That's how it is on like Augur too. It's like the common tasks are about a penny or two, and then like really like the biggest thing you could possibly do on Augur is create like a market, which would be like the 60-cent transaction. just for Ethereum cost or gas cost alone.
Something that people think a lot of the time that's actually not true about the Ethereum network is that it's very powerful. It's not powerful in computing power. It actually has the computing power of a 1990 cell phone, the network itself. The power comes from all the nodes validating, but that doesn't mean they're combining their computing power because everyone's running every transaction and every contract. So you need to watch for, you don't store large documents on the blockchain because storage costs a lot, and every computation that you do within that smart contract costs what's called a gas price or a fee price. So if you go back to your contract real quick,
That's something that was a nightmare to like work with when we were doing because there's so many ideas that we had for the Augur platform just shot down because oh, that won't work on a 1980s computer. We can't do that.
Yeah,
We
so
can't
like-
get the median of thousands of numbers.
Right.
and
It's
how
too
many
expensive.
lines of code is like the Augur like contracts, do you think?
Oh, I don't know how many total.
but
I'll
it's
guess a
definitely
thousand.
more than these 17 we have up on the screen. So if we look at it, instantiating a contract is like a base minimum fee, right? So it's a base minimum, let's say a fourth of a penny. Then to do an event, that costs like an eighth of a penny, and then to make a function, if the function involves addition, that's cheaper than a function that involves computing a hash. And there's a whole chart of what computational steps, and if anyone's familiar with assembly, there's things where you have like the very basic add, multiply, subtract, different things like that. They all have different price values. And the cool thing is the market decides kind of how much they want to charge you for running your transaction. So there's Ether, which is the cryptocurrency, and there's gas, which is the articulation of the fee and the fuel that run the network. So how you figure out how much Ether you have to pay is the gas price, so the computation price, times the gas fee, which is what the miners decide.
And the gas price is denominated in Ether, yes?
The gas price is denominated in Ether, yes. And so you multiply that by the gas fee that the miners are offering right now. So they'll say, you know what, I'll process your transaction for 0.00005 Ether. And so you multiply that times the actual computational fee, and then you have your actual price to do the transaction in Ether. But gas is not the same thing as Ether. It's an abstraction in order to allow you to have this kind of gas thing. Because if you didn't have gas in Ethereum, what if you ran a transaction infinitely? That would take the whole network down. So this gas makes sure that I can't do a transaction that'll clog the network like you can in Bitcoin, where you can send all these little transactions, because it costs a lot of money after you do a lot of transactions or really big computations or infinite loops. It actually stops you from doing infinite loops because of that. If you have a transaction and it's going for so long and you don't give it enough gas, you don't give it enough fees, the transaction stops and it reverts back to the previous state. That's the default. And you can have things that escape it and maybe send you back an error code, but otherwise you just kind of wasted your money running something because you didn't estimate enough. Now, if you overestimate, they give you a refund, so that's fair, because you kind of, it's just kind of a guessing game, just like any fee-based market.
So if you underestimate, then will you go ahead and spend all that gas? The miner will say, thank you very much, but I can't run your contract.
I think that the contract will refuse to
It
execute.
reverts out. It reverts after, it'll start to do all of the actions you requested, and as soon as it runs out of gas, it'll be like, yeah, that wasn't enough to finish it.
And it
I'm
sends it back to
undoing
you.
everything you sent to me and keeping the money.
Yep, it keeps the gas.
Yeah.
So that's one of the things that kind of seems bad, but when you really think about it, in the sense of how complex the system is, it's kind of needed. Like it's the thing that prevents these infinite loops, and it's the things that keeps everything in check and prevents a ton of the problems the Bitcoin network's having right now with people clogging it with transactions or running very, very large transactions or block size. It makes it a lot more scalable, I feel like.
Now, am I
Maybe a
mistaken,
refund
but is the
later,
minimum gas price right now for mining set at a set price, and people want it to go lower? Because when the current gas price was set, it's actually set statically, or at least it's not easy for the miners to properly set it within their command line configurations. But on the next release, at least in the Homestead release, that should be a much easier configuration to let miners allow a much lower gas price because of the deflationary value of Ethereum, at least as of late, right? Because that shouldn't have cost a penny to do that. That should have cost a fraction of a penny, right?
Yeah, I was wondering about that, cause like if the Ethereum price goes up, like, cause like I have like, when I was working with, on doing various, smart contracts, it was like, I have like this Excel spreadsheet that has the gas cost of every action from multiplication to storing data, everything like that. And it seemed like it was fixed, like that wasn't voted on.
Yeah,
You're saying
yeah.
that that's gonna change.
Yeah, I at least know that they're gonna make it easier for a minimum gas price to be set.
Yeah, so it's
Okay.
a default, so every miner has a configuration file and it comes with a default gas price. The miners can change that, and so they announce to the network, they say, hey, I'm willing to go lower. And if enough miners do that, that becomes the consensus and the new gas price. So miners use consensus to change the gas price.
Oh, okay.
Here's the problem. Miners just run their thing and they never change their configuration file. So it's the problem of having a default configuration file, no one goes in and changes it because they're like, oh, I'm fine with this. But really, they need an easier way to change it, and that's what homesteads do. They're putting a new default that's lower and better, and they're also, I think, giving miners maybe a little more instruction, or there's gonna be more, it's gonna be laid out a little more cleanly for the miner to be able to change that, because you have to go into a configuration file and like manually do it, instead of doing even, I don't even think you can do it on a command line for most of the mining clients, so.
Yeah, it should be using interface and
Yeah.
done properly, yeah.
I agree.
So that's it for the agenda. What I wanted to do now is open it up for discussion. Just on one of the questions that I wanted to open up for discussion is, where do y'all want this group to go? What do y'all think is valuable? I don't know if y'all know this, but Hudson is actually the mod of our Ethereum Reddit. And on the Ethereum Reddit, there's a couple of rules. One is obviously no bashing Bitcoin. I don't want to use the group to do that. I think it's a fantastic technology. The people around it are just extremely intelligent. Second thing is I don't want the group to be price speculation. I'm not saying it's outright banned, but at least I like to follow that rule in terms of, at least in the spirit of. Obviously, we're going to talk about the value in terms of talking about gas price and stuff like that. So, would y'all agree to that we kind of focus on the technology within this group and not necessarily coin speculation? You can go anywhere to do that, really. You can go to the troll box on Poloniex and do
I
that all
mean,
day.
I don't think that'd be a major problem with this group, because y'all seem like y'all care more about the application development side than the price side, because just to put it in perspective, like Ethereum has been as low as 60 cents and as high as $10 today was the high in the last 3 months. So that's a ridiculous climb. And so it can, some people who are really into cryptocurrency trading, they'll come to events and kind of spoil it. But I mean, I don't think anyone here is a high frequency cryptocurrency trader. So.
And can we have a show of hands how many people are actually developing on Ethereum in this room?
Yeah, how many we got here? 1,
So-
2, 3, 4, 5, 6. Yeah.
That's actually pretty impressive. I don't know if y'all know this, but the North Texas contingency of Ethereum is actually pretty good. We have an Augur developer, we have an entrepreneur who's starting a company on Ethereum, we have one of the community leaders, and if y'all go through the meetup, and I'm not going to say who they are, but if y'all do your own homework and go through the roster of our meetup, you're going to find CTOs of IBM, you're going to find CEOs of technology companies. It's pretty impressive, the roster stuff. There might be here, I don't know if they want to say who they are and reveal themselves, but I know that we have.
They're not here.
Okay.
But I'm pretty sure, well, actually one of them might be here, but I know one of them was going to come and then he couldn't make it.
Yeah, so one of the guys is actually speaking at MIT today, right? So he couldn't make it because of that. So it's a pretty impressive roster, and this is a really good turnout for the second meetup. Number one, not number 0, but number 1, the second meetup. So y'all can help shape the direction of the group. Where do y'all want to go? I mean, I'd definitely like to have a walkthrough of the Augur platform.
And Dynamis, definitely.
Yes, absolutely. Would you be willing to do?
Sure, I think so. Actually,
Or-
the good news is that we have Quick Left, which is, so Piper Merriam, he presented at DevCon 2, and he works in Boulder, Colorado,
Mhm.
for a company called Quick Left. So they're gonna be the official developers for the Dynamis platform.
Oh, awesome.
Awesome. I love Piper. He's a friend of mine.
So he's local? Or he's in Boulder?
He's in Boulder.
Okay.
He's in Boulder.
So,
So, okay.
So, yeah, there's a lot more development work to be done, but,
Okay.
yeah, you know. I
Maybe
think-
when it's a more
When it's a little more mature,
more
feel free.
packaged, you want to
Yeah.
obviously you don't want to you know, because we broadcast we're broadcasting this and we'll have a video online of my blinking lights.
Yeah.
It's got a very variable scope with it. It can start. It's like the initial starting is doing just unemployment insurance. Then you can be able to expand to any kind of insurance. Then you can talk about taking over like all of
The world.
government
The world.
unemployment insurance.
The world.
The world.
Yeah, yeah.
My goal is to take over the world.
I have an insurance background, and it was really fun to actually go back to London because when I was there before, and the first time I met Hudson was in London. We both live in North Texas, and met him in London. Weird, right?
Yeah.
But I used to do I lived in London because I did an internship for a broker, an underwriter of Lloyd's in London. So I actually went back and saw an old friend who'd done a risk management startup and doing really well, and was fascinated by the technology because we were there for the conference. So I think insurance is going to be a fantastic application.
So when's-
I'm really excited to have it.
I think once anything can be insured, I'd be more excited about seeing that than I would be seeing about Augur. I mean, that's like insurance, like that's ownerless, would be the basis for dispute resolution organizations. 'Cause
Yeah.
there's actually financial motive to go out and stop the guy that's smashing all those cars. That's
Yeah.
making you do payouts.
Yeah,
Like,
no,
you've got,
absolutely. Like the
incentives to
the
replace
adjuster
government already in
has
place.
become the arbiter, right?
Yeah.
Like that's I love that model. That's fantastic.
So, if you don't mind, is there a timeline for Augur that I haven't looked in a long time? Is
Well,
there, like-
they can't predict.
the market's not out. It's like a recursive problem because you can't predict it. The market.
Yeah. they need a prediction market to know when they're going to release, really. But finally, like it's so close now that they can actually. It's like it was supposed to be like last Monday, but they just moved it to next one. It's within a week or two that we're going to do
2 weeks.
beta test. This time I'm actually confident in their claims because before I even joined Augur, I knew it was like there's no way that they were going to release when they said they were.
People
But,
call
yeah.
people call Ethereum the most highly anticipated, heavily crowdfunded vaporware because there's a ton of people who say that Ethereum wasn't going to happen.
That's all crowd sales. Like look at Kickstarter. Every Kickstarter project it's a year later than they promised. Just assume whatever someone says in a crowd sale
Yeah.
plus 1
Yeah.
year. That's what that's how I do it in my head.
But yeah, so what I'll do is after this whole thing, and we'll still have Q&A. We have a little bit of time, but I have a website. So I'm actually in charge of rewriting the documentation for Ethereum for Homestead. Or I'm not in charge, but I'm one of the 2 people in charge. So I'm coordinating that effort, and I can send out a link to that. It's actually just docs.ethereum.org. It's kind of a mess right now, but they do have a lot of good information, and I'm thinking in the next week to week and a half, it'll be more or less done. Obviously,
Be organized. Like there's just so many documents on there. It seems.
there
Like,
is,
it's
yeah,
just-
and and I mean, literally, we have 15, 20 contributors. So if you want to contribute, we actually do need some contributors for the harder sections of it. Feel free to jump on, or even if you're just now being introduced to it, if you're used to looking over documentation, you want to say, is this easy, is this hard, that kind of thing. As far as reading it, feel free to give us some comment. I'd love to hear feedback and, get just completely owned on documentation work.
Doing the Augur white paper, like I'm almost done with its rewrite, so
Cool.
you can kind of see that it's done in LaTeX. So
Yeah, we use RST, I think, so. Cool, but yeah, I'll send out links to that. I'll send out this PowerPoint link. It's actually already on the Meetup, but if you just go to the Meetup page, that's where all this is gonna be. So anyone got questions, in general?
If anyone wants to do this project at home, I'll post just a list of links of all the different resources that I pulled from and a couple notes of some speed bumps that I had along the way.
So let's say you wanted to collect money for anybody who wanted, or from anybody who wanted to turn on your LEDs. I'm assuming they could send you some
That's a
kind of
project that you need to
compensation.
look up called slock.it.
Mhm.
That is exactly their platform.
Yeah.
It's a really good idea.
Yeah, because as somebody who, let's just say, works at a financial institution, it's been our interest in the past year or so to work on platforms that allow people to do that kind of escrow as well as smart contracts pertaining to their documentation to get a loan.
Yeah, that would be like the ultimate, right? And then hopefully you would be elevated to the level, to sea level, because you have been implementing that blockchain, but then a lot of overhead goes away with that also.
Right,
at the
oh
same
yeah,
time.
we understand
Yeah,
that. But
yeah.
it's just getting the regulators on board
R3 made an
with it.
Sure,
announcement.
yeah, yeah.
R3, the consortium of banks, made an announcement. They did a 40-bank trial yesterday or like last week or something using Eris Industries platform. Eris guys are really weird and funny and awesome, and they have a really good platform out there for interoperating multiple blockchains and multiple technologies. So a lot of the major, pretty much every like super large international financial institution is on there, and it's growing every day. So that's an interesting article to kind of look up for you guys, and check out Eris, check out a lot of the things we mentioned today.
Cause I've done stuff with Kolu and with Chain.com from the past.
Oh,
Yeah,
cool.
yeah. Chain and Kolu used to be the heavier players. Now I'm not sure exactly where they stand in the whole scheme of things, but they definitely do. I mean, I know Chain worked with NASDAQ, I
Mhm,
think.
right.
So they've been working on that.
I know that there's been some interest from other groups that have messaged me, in fact, that want to talk about the financial applications of Ethereum. So if you want to talk about finance and blockchain and finance, just in general,
Yeah.
that would be a great topic to at least kick us off and have an open discussion
So yeah,
about how
sometime-
that can be used.
Sometimes we're gonna have remote speakers like Ethereum specialists or people from the actual development team come and talk with us. I already am working on some of those connections right now. And then we can also have people just from the community talking about stuff like your banking applications if you feel comfortable, and definitely Augur, Dynamis, all that stuff. So yeah, feel free, just shoot us a message on the Meetup page. I think there's a messaging platform on there, or find us on Reddit, Gitter, all those channels.
Yep.
My name on there is Souptacular, so hopefully that's memorable enough.
Yeah. And everywhere online, I'm Conrad Johnson, just Conrad Johnson. There was a really talented country artist who tried to start that brand, and I completely squashed it before it happened, because I squatted on all of those social links. But yeah, so Souptacular and Conrad Johnson if you want to find us online, or just write a message on the Meetup stuff.
So I did have one question, Conrad. So are you still working on Groundhog?
Groundhog.
In the social.
Oh, so that's actually a different Conrad Johnson.
There's two Conrad
There's
Johnsons.
there's
One Conrad
just call me
Johnson
James. I'm just saying my
Ethereum space.
there is actually two Conrad Johnsons. One is much more sophisticated than the other, and I am not the one working on the social network on the Ethereum.
So there's
platform.
two Conrad Johnsons who work on Ethereum.
Yeah, I think the other Conrad Johnson is probably much more sophisticated than I in the technology. Yeah.
I see.
Did not know that.
Well, just online. You can call me James. I go by James, but just
James, yeah.
online, Twitter, Facebook, whatever.
And I won't remember any of your names because I'm awful at names and okay at faces. So please, yeah, if I don't use your names. What's your name? Who are you?
So,
I can remember everything but
So,
names.
yeah, I think
That's
we'll just open it up for open discussion. If y'all don't know the person sitting next to you, please introduce yourself to them and just let's have a good time. This is also